Okay, other two have not yet joined. All right, but I'll start. So, good evening. So, today's class is on straight lines. So far, we discussed basics of coordinate systems. We discussed, um, you know, in coordinate systems, how to find the areas enclosed by figures whose vertices are given, like triangle, quadrilaterals, and polynomials. Polygons, and also we um, discussed the concepts of locus and a change of axis. Now we come to this basic, one of the first basic chapters on coordinate geometry, that is straight lines. So, what is the definition of a straight line? So, be with me, you keep writing with me, and then I'll do problems also. So, right on the first degree, the first degree equation in x and y, that is ax plus by plus c equal to 0, represents a line this means that all points x comma y satisfying the above equation lie on the straight line. Okay, so ax plus bx plus c equal to 0 represents a line. It means that, you know, any point on the line, if the equation of this line is ax plus by plus c equal to 0, then any point on this line will satisfy this equation. That means when you substitute the point, you will get 0. When you substitute x and y in this equation, you should get 0. So now, line is a locus, of course. It's a locus of points which satisfies this particular equation. Now, here in this equation, ax plus by plus c equal to 0, a, b, and c are constants. Now, they are dependent constants, they are not independent constants, because here there is 0. Because we can write this, divide the whole thing by c, then you will get a by c plus b by c plus 1. So you can write, that means we just require two conditions. We say, I'll just show. Alternatively, uh, if we divide by C. We get A by C x plus B by C y plus 1 equal to 0, or we can write this as AX plus BY plus 1 equal to 0. So now they are A and B are independent constants. Here small a, small b, small c are dependent constants because you know, if you find two of them, third one will be in terms of the other two. You can find that. Now, because there are two unknowns, you have converted the same equation to this one, and there are two unknowns, A and B. So, to find the equation of straight lines from the above, we can understand that to find the equation of the straight line, we require two distinct conditions. This is very, very important. Based on, if you think in terms of this, this will help you solve all problems. Okay, just take this down. So very clearly, see, what I just did is small a, small b, small c. I divided by c, converted this small a by small c as capital A, small b by small c as capital B. So I get ax plus by plus c. Sorry, ax plus by plus 1. So I have only two unknowns, A and B. Now, to find these two unknowns, I need two distinct conditions. If I have two distinct conditions, I will be able to find the equation of the line. So this is the critical point. So this is the basic definition of a straight line. Into the important concepts, slope or gradient of a line.
Excuse me, sir.
Yes.
So, how will we define dependent and independent constants in general?
Who is asking?
Sir Harshita.
Yeah. How do we understand dependent and independent? Now you see here, in this equation, this capital AX plus capital BY plus 1, uh, one is a known constant. These two are unknown constants. We cannot reduce it further. If we are able to reduce it further, then those will be the independent constants. Here ax plus by plus c equal to 0 is there. Suppose ax plus by plus c equal to 1 was there. Now this becomes no, if it's 1, again you can write it as 1 minus c. Again it will be 2 uh, independent constants. So generally independent constants has to deal with, you know, the number of variables you have, x and y. All right.
Yes, sir.
So with that you can find a thoughtful question. Good question. Now equation of a the slope of a line. How is slope of a line defined? Now this is a straight line. Now we make the angle that the straight line makes with the positive direction of x-axis. We start from the x-axis and calculate the angle till you reach the straight line. So this is the angle. Now this is called as the inclination. Okay, the inclination of a line, the inclination of a line theta is the angle made by the line with the positive direction of x-axis taken in a counterclockwise or anti-clockwise okay, taken in a counterclockwise sense. Now so this is the inclination. Now can somebody tell me what will be the minimum value of the inclination and maximum value of the inclination? Yeah, anybody? I've not yet defined slope, but I'm first defined inclination.
So I guess the slope is to y2 minus y1 upon x2 minus.
No, I've not yet come to that.
Then
My
So 0
my
to 180 degrees.
yes, 0 to 180 degrees. Very good.
oh,
Very good. See this. See this. If the line is horizontal, so I'll draw another line with red. If the line is a horizontal line, the inclination of this line is either 0 or 180, isn't it? Okay, it is 0 or 180 because with the x-axis it is making 0 degrees or it is making 180 degrees. All right. So theta varies from 0 to 180 degrees. This angle from 0 degree, it measures to 180 degrees. Okay. Now see, observe this, 180 is not included because if it comes to 180, it is same as 0. Like x-axis, for example, x-axis, it makes 0 degrees with itself or it makes 180 degrees with itself. Because straight line here, we are not considering it as a directed segment. It doesn't have any direction. So its inclination will always vary between 0 and 180. Understand? Or in terms of radians, it is how much? 0 to pi radians. Okay, this in degrees. Pi radians is equal to 180 degrees. Okay, that's the angle measure. Pi radians is equal to 180 degrees. So now say I can say that this line has inclination From, from x-axis, I can take inclination like this. All right. But whether it is, see, this is total 180 degrees plus theta. So theta plus 180 degrees will give you the same line. So whether the inclination is theta or theta plus 180, you will get the same line. So basically, we take the minimum. It is theta. Theta is the inclination. Got it? Up to here, did everybody get it? We can call this as this inclination of this line is theta. You can also calculate it this way. However, we take the least one. All right. So least one, it is theta. So now the line can also be, I'll take another color, maybe green. Now the line can also make an obtuse angle with the x-axis. So with the x-axis, this is acute angle, this is zero angle, this is obtuse angle. Okay, this also is theta. So that's why theta can vary from 0, it all the way goes to 90 perpendicular and 180. Okay, next. So how do we define slope? Very important, slope or gradient.
So x2
Yes.
minus x1 upon, sorry, y2 minus y1 upon x2 minus
Yes,
x1, I think.
yes, that I am coming to that. I'll show that
So that
gradient.
is a gradient one, right? I'm not sure.
That is the gradient, but
Oh,
I have not yet defined coordinates at all.
oh, okay, sir.
Okay. Now, slope is defined as slope or gradient of a line is defined as the tangent tan ratio. Okay, tangent of the angle of the inclination of the line. Okay, this is the fundamental definition of slope. Okay, and it is denoted by m. Therefore, m is tan theta. Okay, m is tan theta. This is the basic definition of slope or gradient of a line. Beyond this, there are other definitions, but this is the fundamental definition. Now, theta, so slope, so when theta is acute, okay, so note, first part, if theta equal to 0, then m is tan 0 which implies m is equal to 0. Tangent of 0 is 0. Tan ratio. We'll again come to trigonometry, but basic class 10 trigonometry. So therefore, slope of any line, slope or gradient of any line parallel to x-axis is 0. Very important result. Okay. Next, if theta is greater than 0 but less than 90 degrees, if theta is, so 0 less than theta less than 90 degrees, so we read it as theta lies between 0 and 90 degrees. So if theta lies between 0 and 90 degrees, then tan theta is a positive value. Okay, tan theta is a positive value, which implies slope m is positive. Okay, so this is a positive inclination. This in the previous one, here only I'll mark here. This has positive slope. This line parallel to x-axis has 0 slope. Okay, next, if theta, gradually I'm increasing from 0, then I went into an acute angle, and if theta is 90 degrees, then what happens? Tan theta is not defined. Actually, what you get, tan theta is sine theta by cos theta. Tan theta is sine theta by cos theta. Cos becomes 0. All right. Now, when cos becomes 0, a number divided by 0 becomes, it reaches infinity. Meaning 1 by 0 is not infinity exactly, it is undefined. All right. Remember, 1 by 0 is undefined. 1 by a number which is approaching 0, very, very small number, it becomes infinity. But 1 by 0 is an undefined number. Do not confuse. Here in this case, we say slope m should be undefined, but we say slope m is infinity for a reason. Because your tan values will start from 0 and approach infinity. Okay, so m, actually slope m is undefined at that situation, but common notation is we write m is infinity. All right, so this, okay, I'll come back to the final statements. So what is the observation here? Any line parallel to x-axis, therefore slope of any line parallel to y-axis is infinity or undefined. Got it? Lastly, if theta is obtuse angle, that is, it lies between 90 degrees and 180 degrees, then tan of that theta is negative, which implies slope m, which is equal to tan theta, is negative. All right, so the line is negatively inclined. This is positively inclined, this is negatively inclined. So coming here, this line, this green line has slope negative. So again, horizontal line has slope 0. Any line which has a acute angle with the x-axis will have positive slope. Any line which is vertical will have undefined or infinite slope, and any line which makes an obtuse angle with the x-axis which will have a negative slope. So why do we say negative or positive? So a gradient, understanding of the gradient is like this. Say when we go along the line, let us move in the positive direction of x. When we move in the positive direction of x, this yellow line is moving upwards. Correct? As we are moving in the positive direction of x, the yellow line is moving upwards. Therefore, we call it as a positive gradient. You are moving forward and you are going upwards. That is called as a positive gradient. When we move along the positive x-axis from the left to right, then this green line is going downwards. The green line is going downwards. So we call it as a negative gradient. Clear? Why positive gradient and why negative gradient? When we go in the positive direction of x, if the line is going upwards, it is called as a positive gradient or positive slope. When we are going towards right and the line is going downwards, as we move towards the right, then it's negative gradient. Clear? So that is slope. Now slope of a line joining 2 points. Now slope gradient, we are talking about gradient. We talked about inclination, we talked about slope, and now slope in terms of coordinates of 2 points on a line. In other words, this is also said as slope of a line. I'll write this like this. Slope of a line joining 2 points A x1 comma y1 and B x2 comma y2 is M is equal to y2 minus y1 by x2 minus x1. How do you get this? Very simple, based on our basic definition. X, y. So let's look at a line. This is a line. Now, there are 2 points on this line. Let's say A, I'll write it here, A and B. The coordinates of A are x1 comma y1. Coordinates of B are x2 comma y2. All right. So now you just draw perpendiculars. We are just dropping perpendiculars from A and B and draw a line parallel to x-axis like this. Okay. Now let this inclination be theta. Now what will be this angle? This angle will also be theta. Why? Because it is corresponding angles, right? In your geometry, plane geometry, these two, they are two parallel lines, and there's a third line that is cutting the two parallel lines. This angle and this angle will be equal because these two are corresponding angles. So here see, this is a line parallel to x-axis. So this angle and this angle will be corresponding angles. Now, what is this length? Okay. See, what is this length? See, this whole length from the origin to this point, say a dash b dash, we can write. See, this OA dash will be x1 and OB dash will be x2 by the definition of coordinates. All right. OB dash will be x2. This is the x coordinate in the x direction. OA dash will be x1. So what will be a dash b dash? It will be x2 minus x1. Correct? And because this becomes a rectangle, because this is perpendicular, two adjacent sides are perpendicular. All right, and we have drawn a horizontal line, so this length equal to this length, so this is a rectangle, so this length and this length are equal. Okay, let this point be C. Now what is this length BC? This length BC is this B dash B is y2 and B dash C is y1. See this level y1. So this BC will be y2 minus y1. Okay. So from the figure directly you can show, from the figure in triangle ABC, tan theta is opposite side by adjacent side. Opposite side is y2 minus y1, adjacent side is x2 minus x1. Therefore slope M is equal to y2 minus y1 by x2 minus x1. Okay, this is the gradient.
Excuse me, sir.
Yes.
Sir, can the same slope can we apply it in so in modular, sorry, not modular, so dx by dy?
Yes, that is differentials. Yes,
Yes, sir.
that
But
you will
they
come.
technically that is also slope only.
And when I come to that, I'll explain. That is also exactly this. When you say differential, your
Yes,
distance
sir.
between AB
Is
distance
zero.
is very, very small. It's
Yes,
not
sir.
zero, it is approaching zero.
Yes, sir.
So then see what we write here. I'll just explain for you to. What we write here as x2 minus x1, we can say is difference of x. difference between x, we write it as delta x, and difference between y, that is delta y. So when we come to differentials, we will learn this. So this delta y by delta x, as this delta x values approaches 0, is derivative. So that derivative is slope of a tangent, so slope of a line only. So in differential calculus, we'll learn this. Okay. So that and this are the same, but that has a specific application and connotation. All right. When we come to differentials, we'll discuss that. So here, see gradient, now you can understand like this. Gradient means I want to see how fast is my slope changing. So that means if I travel a distance, this one, x2 minus x1, how fast is my y changing? If y is changing slowly, then this ratio y2 minus y1 by x2 minus x1 will be small. Okay. If this is rapidly changing, that then you will get a very steep line. In the steep line, we say slope is high because y2 minus y1 will be very large compared to x2 minus x1. Okay. So the lines which are more inclined towards the x-axis have lesser slope. Lines which are more inclined towards y-axis has greater slope. Now line which is inclined at 45-degree angle, what will you say about it? When the line is inclined at 45-degree angle, when this is 45-degree, this is 90. This angle will also be 45. So what do you get? You get a right angled isosceles triangle, 45 degrees, 45 degrees, 90 degrees, which means AC and BC will be the same, equal. Y2 minus y1 is equal to x2 minus x1. So slope is 1. When theta equal to 45 degrees, x2 minus x1, it will be equal to y2 minus y1. Therefore, m is equal to 1. When you say slope equal to 1, it means line is inclined 45 degrees with the x-axis. All right, clear? Next, so these are just all right. Okay. Next, some conditions based on slope. On slope only, this is not over. Slope in terms of coordinates of points, I will write like this. I will renumber these as subpoint within slope, subpoint 1, subpoint 2, subpoint 3, subpoint 4. Okay. Comparison of slopes of two lines. Okay. Now, if two lines, having slopes m1 and m2, are parallel, then M1 will be equal to M2. That means parallel lines have same slope. Okay, parallel lines have same slope. Now, if two lines are perpendicular, two lines of slopes M1 and M2 having slopes or gradients M1 and M2 are perpendicular, then product of slopes will be equal to -1. This you will know by trigonometric ratios. Okay, you can show this basic trigonometry class 10. Otherwise, say I'm just using some simple trigonometric ratios. Again, when we do trigonometry, it will be much more clear. But say this: if inclinations are inclinations of the perpendicular lines, let inclinations of the perpendicular lines be θ1 and θ2. Okay, so θ2 is θ1 plus 90 degrees, correct? Because they are perpendicular lines. You know, this line is inclined at theta, and a line perpendicular to it, a line perpendicular to it will be having angle theta plus 90 degrees, isn't it? This is x-axis. So with respect to x-axis, this line is inclined at theta. The second line is perpendicular. So theta plus 90 degrees will be the inclination. So tan of θ2 will be tan of 90 degrees plus θ1. By trigonometric ratios, this is cot θ1. Okay, this is cotangent. So product of slopes, therefore, oh sorry, this is minus cot θ1. So product of slopes M1 into M2 is tan θ1 into tan θ2, which is tan θ1 into minus cot θ1. And what is cot? Cot is a reciprocal of tan. Therefore, you get M1, M2 equal to -1. You don't worry about trigonometric identities right now, even if you are not clear of these. Do not worry. Our main result is this. You remember this. When we do trigonometry, this is a very simple thing. It's not a big thing. If two lines are parallel, their slopes will be equal. If two lines are perpendicular, slopes will be -1. Product of slopes will be -1. Okay. Now, if suppose now angle between two lines, very important result, very important result. Angle between two lines having slopes m1 and m2 is given by theta, then tan theta is m1 minus m2 by 1 plus m1 m2. Very important result. We'll use this result like anything in problems. This is again a compound ratio of trigonometry. This is trigonometric ratio only. Like I'll give here for proof because these notes will remain with you. As I do trigonometry, you will appreciate these proofs again. Right now, as I'm saying again and again, do not worry about these proofs. Because compound angles and all must have been just touched in class 10th. In detail, I don't know. If you have attended some IIT foundation courses or something like
No,
that.
sir.
Okay. So you don't worry about trigonometrical ratios at the moment. So this is line 1. Okay. Now this is, say, line 2. I'll shift it. Just a second. So this is X, this is Y, and let's say this is line 2. Okay. Now the first line has inclination theta 1, second line has inclination theta 2. So angle between the lines always is taken as anti-clockwise direction, theta. Okay, this theta is nothing but, you observe, theta is theta 2 minus theta 1. Correct? Because if you draw a line which is parallel to x-axis, this is not x-axis, it is parallel to x-axis, from the point of intersection of the lines, from the point of intersections of the lines. So this angle is theta 1 and this whole angle is theta 2. Look at the corresponding angles. Okay, so this theta is theta 2 minus theta 1. Okay, I made a mistake. All right, so now theta 2 minus theta 1. So I need angle between these two lines is this. So what is the tangent. If I do tan theta, it will be tan of theta 2 minus theta 1, and there is a result in trigonometry. This is tan theta 2 minus tan theta 1 by 1 plus tan theta 2 tan theta 1, that is tan theta 1 tan theta 2. Okay, so actually it is m2 minus m1. I'm sorry, this is m2 minus m1 for this particular case. Now it can be m1 minus m2, it can be m1 minus m2 for this obtuse angle. See, when lines intersect, always there will be one acute angle and one obtuse angle. So actually this is m2 minus m1 by 1 plus m1 m2. Now for the acute angle, just a second, let me finish this. Now tan theta 2 is the slope m2, tan theta 1 is slope m1 by 1 plus m1 m2. So that's how we get this. There's a proof for that above statement. Okay, this particular statement. Now if you don't know whether it is m2 first or m1 first, many times in straight lines immediately you don't know, you want the acute angle between the two lines. All right, so if you want to get the acute angle between the two lines, acute angle between the two lines with slope m1 and m2 is tan theta is modulus. Just take modulus. Okay, just take the modulus and you get the result, because for an acute angle tangent ratio will be positive. So when you take the modulus you get the positive. If you take the negative value of this, you will get the obtuse angle. Simple, acute angle and obtuse angle. All right, this will give you, if you just the positive value of this ratio, take tan theta, it gives this ratio, then theta will be tan inverse of this angle, tan inverse of this ratio, so that angle will be acute angle. For obtuse angle you have to take this ratio as negative. Okay, I think one or two problems, and now from here you can see conditions for two straight lines to be parallel. If two straight lines are parallel, see here, deductions. If two lines are parallel, then angle between them is zero, theta equal to 0. Therefore tan theta equal to m2 minus m1 by 1 plus m1 m2 will be equal to 0, correct? Which implies if a ratio is 0, that means numerator is 0, which implies m1 is equal to m2. That's what we showed. If two lines are parallel, we said that the slopes are equal. All right, now if two lines are perpendicular, If two lines are perpendicular, then angle between them is 90 degrees. Therefore, tan 90 is undefined infinity. Okay. All right. That happens if the denominator is 0. If the denominator becomes 0, this happens, which implies m1 m2 equal to -1. All right. So today we just discussed up to slopes only. I just discussed basic equation of line and definition of straight line and slopes and results of slopes. All these results of slopes is very important. Tomorrow's discussion will be equations of straight lines in different forms. Very important. We had to had a detailed discussion of slope, and now equations of straight lines in different forms. Before that, I'll give some simple questions on this, one or two examples on this, and then we'll continue with equations of straight lines in different forms. And once this is ready, we are ready for multiple problems of different nature in straight lines. Once we know these equations of straight lines in different forms. All right, any questions for today? Any questions?
No, sir.
Okay. All right, I'm trying to give a quiz. So on coordinate systems, simple quiz, 10 questions. I'll try to load the quiz by tomorrow. Your weekdays may be little hectic for you, but I'll give an open time. So maybe of 2 days, where the quiz timing will be 30 minutes only, but 30 or 20 or 30 minutes. I'll give 30 minutes first quiz. So you can enter and start solving the quiz. The quiz will end in half an hour for you. All right. So I'll try to give a quiz on coordinate systems soon. All right. Thank you.
Thank you, sir.